Hello guys, welcome back to my YouTube channel, Rahul GPAT Academy. So, from today onwards, I am going to discuss regarding important topics for the TS PGECET point of view. Nothing but the Telangana state PGECET exam के लिए. So today onwards, I am going to discuss regarding few important topics which will be more useful for your exam. I think around we're having 4 days, so 4 days more than enough to get under 500 rank uh, from my whatever I will discuss from those classes. More than enough because last year also I did when I was teaching in Viper. Only 3 or 4 days I have taught them, and from them like around 22 members got rank under 500. So this is Rahul Mullah. So I have done my M.Pharm from Jadavpur University in Pharmaceutics. Now I am pursuing my PhD in Department of Pharmaceutics, Yenapa Pharmacy College and Research Center, Yenapa University, Mangalore. So as I was doing or as just recently joined in PhD program, that's why from last few month, like 2 months, I did not upload any videos related to GPAT or any competitive exam. So now onwards, I'll continue it soon properly. So today I'm going to discuss regarding pharmaceutics. I thought I will complete the pharmaceutics topic in one video, but it's getting longer. So that's why I am discussing today on physical pharmacy as well as pharmaceutical technology, remaining important topics from pharmaceutics as well as like jurisprudence and pharmaceutical microbiology. In next video I'll discuss. After that I will upload one more video for pharmacology and another video for pharmaceutical chemistry. So in this way, within 4 days or 4 to 5 classes, I can complete the most important topics, which will be like important or most important for you guys for the TSPG set exam. Hope for the best. Okay, let's start. So first day, I am going to discuss regarding physical pharmacy. In physical pharmacy, one of the most important topics like micromeritics. Micromeritics nothing but the science of technology where we have to study regarding the small particles. That's nothing but the micromeritics. So what are the important topics from micromeritics you have to study? Nothing but the flow properties as well as method of particle size distribution. Definitely you are going to get minimum 1 to 2 questions from these two table. Okay, 100% guarantee. So flow property, what it means? Nothing but the flow of powders. How it will flow? Nothing but the excellent, whether it is excellent or good, fair, poor, very poor or very very poor. Based on the different values like Car's index, angle of repose as well as Houston ratio. Okay. So last time if angle of repose came, then this time definitely you are going to guess Houston ratio or Car's index. Like this you have to remember. Like if Car's index value 5 to 15, then it will be excellent. 12 to 16 good. 18 to 21 fair possible. 23 to 35 poor. 33 to 38 very poor. Greater than 40 it's around very very poor. Angle of repose 25 to 30 excellent. 31 to 35 good. 36 to 40 fair possible. So these things you need to memorize. Try to remember or memorize this table as much as you can, please, because definitely you are going to get one question from this table. Next I am going to discuss regarding method of particle size distribution. So nothing but the this is also one of the most important topics for your PG set point of view. So here you have to like most of the time they will be asking this one like sedimentation. Actually in GPAT or NIPA most of the in competitive exam also from this one only they used to ask, as well as Coulter counter also important, and microscopy, optical microscopy also important. So these things need to remember, like by using optical microscopy directly you can measure. By directly measurement, nothing but the optical microscopy. Sieving nothing but the based on the separation of particle size. Separation of particle size based on particle size. Okay, separation of particle based on particle size. In case of sedimentation, nothing but the Anderson pipette apparatus. This one you have to remember properly. Anderson pipette apparatus, as well as in sedimentation, one more time you have to remember Stokes law. These three things you have to remember, And the main principle of sedimentation, nothing but the rate of settling. This can be asked. Rate of settling depends upon the rattling settling based on the particle diameter also. If the particle diameter more, means rate of settling will be higher. Means more unstable. Okay. And what are the instrument used in the for the measurement of particles by using sedimentation? Anderson pipette. Anderson pipette. This one you have to remember properly. Then Coulter counter, also known as Coulter, like instrument Coulter counter or HISE or Royso. These are the things you have to remember properly. So from Micromeritics, you have to remember properly nothing but the flow powders. These two tables, particle size determination as well as flow powder. Next, like surface tension. One more important topic from physical pharmacy for PGCET point of view. Okay, last time also one or two questions came from this uh, PDF only. From my PDF only 1 to 3 questions came. Last time I already told that around 22 members from under my guidance got under 500 rank in TS PGECET. So definitely you are going to get 1 or 2 questions from each topic. So try to be like concentrated on this topic only. No need to read more. Whoever like did not start till now regarding for the preparation of PGCET, please start from today onwards, and just 4 days more than enough to get under 1,000 or 500 rank. Okay. So surface tension nothing but the tension or force. Okay, tension or force per unit length that must be applied parallel to the surface to counterbalance the net in out pull. Okay, so no need to remember this definition. It's not semester exam. So what are the things you have to remember? Now what is the unit of surface tension? Now unit has dyne or dyne per semi. You have to remember the unit dyne per semi as well as Newton per meter in SI unit. CGS unit dyne per semi and SI unit Newton per meter. One more thing you have to remember, surface tension is the indication of cohesive force. Surface tension is the indication of cohesive force, and interfacial tension is the indication of adhesive force. Is the indication of adhesive force. These are the things you have to remember properly. And water having the surface tension of 72.8 dyne per centimeter. And what is the formula to calculate or determine surface tension? Gamma. Gamma equals to FB by 2L, where gamma is surface tension, FB is nothing but the applied force, and L is nothing but the length of surface. So next we are going to discuss regarding surface free energy. One of the most important, like last time they have asked like surface tension, so maybe they will ask this time regarding surface free energy. Maybe they will ask the definition or the formula to calculate. So surface free energy nothing but the to move a molecule from the inner layer to surface. What of the work need to be done? That nothing but the surface free energy. That's it. Okay. Higher the surface free energy, higher the surface of the liquid, more the molecule have this excessive potential energy, means more surface free energy. How to calculate now? W equals to gamma into delta A, where W is nothing but the work need to be done. Gamma is nothing but the surface tension, and delta A nothing but the increased surface area. So this formula try to remember properly. And the surface tension of the most of the liquid decreases. In case of liquid, surface tension decreases with increasing temperature. So indirectly proportional with temperature. In case of surface, in case of liquid, in case of liquid, indirectly proportional. But in case of gases, directly proportional. Why? Because now more temperature means more Brownian motion, more pollution, head and collision means more like surface tension. Okay, in case of liquid, surface tension get reduced with increasing temperature, but in case of gases it will be like reverse. Now we will discuss regarding HLB scale. One more important topic, like HLB, nothing but who discovered the Griffin. Last time, fortunately, I discussed many times in the classroom before exam also, and they have asked Griffin who discovered HLB scale. So it's also important. Maybe this time they will not ask, but HLB, nothing but the hydrophilic lipophilic balance. Who discovered now? Griffin in 1947. It determines the hydrophilicity as well as lipophilicity of any compound. How to calculate? HLB equals to 20 into 1 minus S by A, where S is nothing but the substitution number, A is nothing but the acid number. Another formula, HLB of surfactant nothing but the hydrophilic group minus hydrophobic group plus 7. What you have to remember? Now HLV value of SLS, sodium lauryl sulfate, is nothing but the 40, triagon 30.13.2, acacia 8. One more is the GMS, glycerol monostearate 3.8, GMS 3.8. So these are the things more than enough for HLB, and this table you need to memorize for HLB scale, like 1 to 3 antifoaming agent, 3 to 6 water in oil, 7 to 9 whitening agent, 8 to 16 oil in water, 13 to 15 detergent, 15 to 18 solubilizing agent. And now whitening agent. Whitening is also one of the more important topic from the PGC, for the PGCET point of view. So what is whitening agent? Now whitening agent is nothing but the one type of surfactant. When dissolved in water, it will lower the contact angle, so it will be like easily dispersed. Okay, it will be like easily it will be spread out. That's nothing but the main function or principle of whitening agent. So need to, like, what is the contact angle? If the contact angle of to 0 means complete whitening. These two important topic, these two important point you have to remember. Contact angle 0 means complete whitening. Contact angle 180 degree means non-whitening. Okay, maybe you will get from these 2 points. One question maybe you will get. Okay, if any question will come from whitening agent, means this one definitely you are going to get. Like contact angle 0 means what it signify? Na complete whitening. 180 means non-whitening. Okay, 0 means complete whitening. Baki means 180 like nothing but the non-whitening. Okay, so next you have to discuss, we are going to discuss regarding rheology, one of the more important topic, rheology. So rheology nothing but the, rheology means nothing but the Greek word rheos and meaning flow. So rheology is nothing but the study of deformation of matter, study of flow of deformation of matter under the influence of stress. That's it. You don't need to remember definition and all. Deformation of matter, that's enough. Or flow of fluid, that's enough. Rheology. Okay, but you have to remember different fundamental concept, like what is elasticity, what is pure viscosity. Elasticity means a property of solid material, elasticity for solid, and viscosity for liquid. Okay, so elastic material also known as Hookean body, also Hookean body. And in case of Hookean body, stress is directly proportional to strain. Okay, stress is directly proportional to strain, and if we will remove that stress, again it will get its original shape. That's the elastic property. How we have to calculate? The dl equals to sigma by E, where E nothing but the Young modulus. E nothing but the Young modulus. And pure viscosity, viscosity is nothing but the property of liquid which will resist its continuous movement during the apply, if we will apply force. Okay, no restoration motion follows after the removal of the deformation force. It is a permanent or irreversible deformation. So viscosity is nothing but the permanent or irreversible deformation. Viscosity is the property of liquid material and is explained by Newton's law. Based on the Newton law, we have like classified like into like Newtonian, non-Newtonian, and non-Newtonian will be classified into like uh, independent, time independent, time dependent, time independent, under time independent, like plasticity, pseudo-plasticity, as well as dilatant and time thixotropy and rheopexis, spores, bars, and all the things. So viscosity, internal friction in the fluid. Viscosity, internal friction in the fluid. That means resistant to relative motion of the adjacent layers of the liquid. In the CGS unit, what you have to remember, what is viscosity? Internal friction of the liquid. What is the unit? Scissors unit, gram, semi inverse, second inverse, or poise. Poise. And viscosity of water, 1 centipoise. What internal SI unit? Pascal. Scissors unit, poise, SI unit, Pascal. Okay, and SI unit of viscosity is Pascal second. 1 Pascal second equal to 10 poise. Pascal is the unit of stress and dimension Newton per meter square. So You have to remember what you have to remember. Now, what is the unit of viscosity? Now, Pascal second. Now we have to remember few terms like fluidity. One of the most important term, fluidity. What is fluidity? Now reciprocal of the viscosity. Inverse of viscosity, nothing but the fluidity. If viscosity high, fluidity low. Viscosity low, high fluidity means it will be spread easily. That's it. One more term, kinematic viscosity. Kinematic viscosity, nothing but the neutrino viscosity or absolute viscosity that divided by the density. So viscosity by density, that nothing but the kinematic viscosity. What is the unit of kinetic viscosity? Stokes and centistokes. SI unit Stokes and CGS unit centistokes. Temperature dependence. It is one of the most important point from this. You may get one question from this Arrhenius equation. Okay. So temperature dependence of viscosity. How the temperature affect the viscosity of any liquid? Now viscosity of liquid falls. So false means the viscosity of the liquid will be reduced if we increase or rise the temperature. So indirectly proportional will be there in case of liquid, but in case of gases, viscosity will be directly proportional to the temperature. Why in case of liquid it's getting decreased? Now due to decrease in intermolecular force of attraction, because if we increase the temperature, bonding will be break down, so intermolecular force of attraction also will be reduced. That's why viscosity reduced in case of liquid with increasing temperature. So variation of viscosity with temperature mainly expressed by Arrhenius equation. Arrhenius equation, what is the Arrhenius equation? Now eta equals to A e to the power EV by RT. Here A is nothing but the constant that depends upon the molecular weight. EV is activation energy, R gas constant, T temperature. So these things you have to remember. What is A, what is EV, what is R, what is T. You know A is nothing but the constant that depends on molecular weight. EV you need to remember properly. EV activation energy, R molecule gas constant, T temperature, these things. So next we are going to discuss regarding classification of fluid based on the rheological behavior. Now fluid will be classified into Newtonian and non-Newtonian. Newtonian, non-Newtonian. Non-Newtonian do two types. One is time independent, time dependent. Time independent plastic, pseudoplastic, dilatant. Time dependent, thixotropy, rheopex. How to remember? Independent, IP, IPD. IPD means I for independent, time independent. P for pseudoplastic, P for plastic, D for dilated. Baki whatever is there, that nothing but the time dependent. Like thixotropy, diopexy, anti-thixotropy, negative thixotropy, all the things. Negative diopexy. Okay. Here you have to remember regarding bulge and spurs very properly, because maybe you will be asked one question. Last time also they have asked, like they asked for bulges. So now they can ask regarding spurs. Okay. What is bulges? Now, bulges and spurs are the representative of complex hysteresis loops. Hysteresis loops. Hysteresis loops observed in pharmaceutical dispersion. That is bulges and spurs. Bulge is the characteristic feature or protrusion in the up curve. Up curve. Observed in the hysteresis loop of concentrated bentonite. Example you have to remember. Bulge, concentrated bentonite. B for bentonite, B for bulge. 10 to 15%. And in case of procaine penicillin G, procaine penicillin gel, spore like protrusion will be there. Spores gel, procaine penicillin gel, spore like protrusion. These two definitely, please remember these two, either bulge or spores. Example, bulges concentrated bentonite gel 10 to 15%, and in case of spores nothing but the procaine penicillin gel, procaine penicillin gel, spore like protrusion. Few terms you have to remember: plastic, pseudoplastic, dilatant, and its example. Example is important. Neutron fluid. What is the example of neutron fluid? Ethyl ether, acetone, chloroform, water, absolute ethanol, ethanol. Plastic. Any plastic, nothing but the like concentrated flocculate suspension, concentrated. Whenever you will see any concentrated means plastic will be there. Concentrated flocculate suspension, concentrated zinc oxide suspension, semi-solid dose like gel, cream, ointment, like no, these are the things you will be like remember. You have to example. You have to remember this type of example of plastic properties, plastic flow. Here we have to remember like yield value, yield value. So yield value will be seen in plastic bodies, plastic fluids, and such substance known as Bingham bodies. Bingham bodies yield value related to plastic fluid. Okay, plastic fluid related to plastic fluid. You have to remember yield value as well as Bingham bodies. An example. Now pseudoplastic. Pseudoplastic means any type of polymeric solution. It may be agar, tagagan, acacia, gum, gelatin, whatever the polymeric solution, all are pseudoplastic in nature. And pseudoplastic also known as shear thinning system. Shear thinning system. Flocculate suspension also example of pseudoplastic. And dilatant. Dilatant also known as shear thickening system. These two you have to remember. Pseudoplastic, shear thinning, dilatant. D for dilatant means like dilate हो जाएगा, थोड़ा मोटा हो जाएगा, means thick हो जाएगा. So dilatant nothing but the shear thickening system. What is the example of shear thickening system or dilatant? The suspension containing small amount of liquid at high concentration, like more than 50%. Wherever you will see like 50%, more than 50% means dilatant. So next we are going to discuss regarding pharmaceutical technology. Few important topics like suspension, emulsion, tablet, capsule. From where each topic you will get one or two questions definitely. So try to remember all the things properly. Maybe this video will be like around 40 to 45 minutes, but please again I am requesting, just follow these topics. Definitely you are going to get around uh, 8 to 10 questions from this class. 40 minutes 10 question, what you want, I think more than enough. Okay, so now we are going to discuss regarding suspension. Suspension is nothing but the heterogeneous system. Suspension heterogeneous. Why? Because here two different phases there. One is suspended finely divided particle and another one is liquid phase. That's why it's heterogeneous system. Okay, continuous external phase. External phase is nothing but the water phase or liquid phase, and internal phase dispersed particle phase, particular matter. That's its suspension. No need to remember suspension definition and all. No one is going to ask you regarding definition of suspension, definition of emulsion in this such type of competitive exam. You have to remember like few important things. Nothing but the tables. Very important table. Like this table also important. What you have to remember? What is sedimentation volume? What is the formula of sedimentation volume? If sedimentation volume value is 1, what it means? 0, what it means? Like that way you have to remember. Degree of flocculation. What is degree of flocculation? How to determine? These things you have to remember. What is sedimentation volume? Sedimentation volume is nothing but the volume initially and actual. That's it. VU by V0. That's nothing but the sedimentation volume. So the ratio of ultimate sediment volume, ultimate sediment volume to the initial volume, VU by V0. That's nothing but the sediment volume. If sediment volume F equals to 1, then it's called as flocculated suspension. Nothing but the ideal stability. Okay, 1 means flocculation equilibrium, 0 means no flocculation will be there. Deflocculated system. Degree of flocculation, beta equals to like sedimentation volume of flocculation suspension, flocculated suspension by sedimentation volume of deflocculated suspension. That ratio is nothing but the degree of flocculation. One more important table is like different terms or instability related to suspension, like particle state, rate of sedimentation, sedimentation nature, redispersibility, appearance, caking, rheology nature. So these things you have to remember properly. Please go through these tables. If you want these notes, that also I can provide you. Please comment if you want notes of this, like PPT or note PDF of this lecture. I will definitely provide you for you guys check. Okay, so don't hesitate. Please ask the note regarding notes or PDF if you want. Definitely it will be helpful for you for the PGCET exam, definitely. So now emulsion. Emulsion also one type of biphysical liquid form, thermodynamically unstable. Emulsion is thermodynamically unstable biphysics. That is suspension, and suspension is stable. Okay. Here both the phases liquid in nature. One phase will be oil, another one is water. Maybe oil in water or water in oil. Based on that, emulsion will be classified in two types: oil in water emulsion and water in oil. Oil in water means oil in water means oil कम है, water ज़्यादा है. Like we are getting marks 20 out of 50. 20 by 50 means less marks we are getting, means whatever will be in above position that will be less. Okay, that's the main funda to remember all the things. Oil in water emulsion and water in oil emulsion. Different test is there. You have to remember these tests like dilution test, conductivity test, Emerson dye test, dye test, electricity or current test, and fluorescence test. As well as you have to remember few example like oil in water type of emulsion. What is example? Oil in water. What is example of oil in water? B. Vanishing cream. Vanishing cream. B just look like W only, so WB, WB. Okay, that's it. Oil in water means example will be vanishing cream, and water in oil. O is there means last O means cold cream. Cold cream also O is there, so cold cream is the example of water in oil. These things you have to remember. These things you have to remember, and this table also you should remember, very important. Like what the ratio of oil water gum. These things you have to remember. FMVO, FM radio, FM, FM, V, FM radio volume बढ़ाओ. Okay, so please improve the volume of FM radio. So F4, M3, B2, O1. That's it. 4 is 2, 2 is to 1. This water is to gum will be same. 2 is to 1 every time. 2 is to 1 only. In this one only you have to remember. 4, 3, 2, 1. That's it. FMBO, FMBO. Easily you can remember. History example: castor oil, almond oil, arachis oil, cod liver oil. Mineral oil example: liquid paraffin. Volatile oil: turpentine oil, peppermint oil, cinnamon oil. Oleoresin like tolu balsam, male fern extract, etc. That's it. So try to remember minimum these two tables. Definitely you are going to get one question, as well as these two example: water in oil, cold cream; oil in water, vanishing cream; WV, vanishing cream; O, cold cream. Okay, that's it. Now we are going to discuss regarding capsule. Capsule. What is capsule? Capsule one type of solid dosage form. Okay, like tablet only. Capsule also a solid dosage form, and mainly made up of gelatin. It may be hard gelatin or soft gelatin. Okay, soft gelatin or hard gelatin. That's it. And capsule may be classified either based on that gelatin type, hard capsule or the soft capsule. Okay, hard gelatin capsule. Hard gelatin capsule is nothing but the usually used to contain the dry powder. Hard gelatin, hard material, powder form. Okay. Hard gelatin, hard form or powder form, very small pellets generally enclosed within a hard gelatin capsule. But you have to remember the moisture content of hard gelatin. Hard means more, means 12 to 16. But in case of soft gelatin, less means 6 to 10. These two we have to remember. Last time also they asked regarding soft gelatin, I think. So this time they ask hard gelatin, or if they asked already hard gelatin, this time they will ask maybe soft gelatin capsule. So these two you have to remember. What is the moisture content of hard gelatin capsule? 12 to 16. What is the moisture content of soft gelatin capsule? 6 to 20, 6 to 10, 6 to 10%. Sorry. This thing. One more thing is like capsule size, highest 000, lowest 5. So highest 000. What is the volume? 1.35. In weight 950 mg. That's it. Okay, that's it. So this table you have to remember one few important points or one liners regarding capsule or gelatin. Gelatin is heterogeneous product derived by irreversible hydrolytic extraction of treated animal collagen as well as, okay, that's it. And two types of gelatin is there: type A gelatin, type B gelatin. Type A gelatin isoelectric point pH 9 and type B 4.7. These two please remember isoelectric point, okay, of type A gelatin is 9, type B 4.7, and type A for acid treated, type A, B for basic alkali treated. That's it. And and type A acid means it will pH, it will be opposite in case of capsule gelatin. Okay, that's it. Isoelectric point, so pH will be more 9, and B basic pH will be less 4.7. That's it. And one more thing you have to remember: bloom strength, very important point, very important. I don't know how many times it came in GPAT Neighbor, maximum time. As a different competitive exam also, it came already. So maybe they asked regarding bloom strength or gel strength of the gelatin. This is a measure of cohesive strength of the cross-linking that occurs between gelatin molecule and is directly proportional to the molecular weight of the gelatin. Okay, how it will differ? Now based on the molecular weight of the gelatin as well as cross-linking that occurs between the gelatin molecule. What is the normal value of bloom strength? 150 to 250 gram. This point please remember: 150 to 250 gram. Higher the bloom strength, more the price. Price tag will be more for higher bloom strength. Okay, that's it. The viscosity. What is the value of viscosity? Ideal value 25 to 45 millipoise. And gelatin used in the manufacture of soft gelatin capsule should not contain more than 15 ppm of iron. Not more than 15 ppm of iron should be there in case of gelatin. Okay, so from capsule what you have to remember: moisture content of hard gelatin, soft gelatin. Hard gelatin 12 to 16, soft gelatin 6 to 10. And this table like capsule size 000, highest 000, and lowest 5, highest 000 means 1.35 in ml, as well as in case of weight 950. And you have to remember isoelectric point of type A, type B gelatin, as well as bloom strength 150 to 250 gram, as well as viscosity 25 to 45 millipoise. These things you have to remember from capsule point of view. And next and last for this lecture, nothing but a tablet, one of the most important topic for PGCET point of view. Definitely you are going to get one question minimum, 1 or 2 questions you are going to get. Okay, one question definitely you will get definitely from this slide only. You will get one question minimum, definitely you will get. Different types of tablets are there: compressed tablet, multiple compressed tablet, tubal tablet, film coated tablet, integrated tablet, air pulverization tablet. You don't need to remember all the definition of compressed tablet, multiple compressed tablet, tubal. Okay, what is tubal tablet? It will be chewed with the mouth, and here you have to use mannitol. Mannitol you have to use. No need to use any disintegrant. That's it. Enough, more than enough for tubal tablet. Film coated tablet, thin layer of polymeric film will be there. That's the film coated tablet. Enteric coated tablet, nothing but for the intestinal, like site specific drug delivery. Here one thing you have to remember: the different type of polymer. Whenever you will see like phthalate is there, phthalate is there phthalate is there means enteric coated. Effervescent tablet means it will be like evolve carbon dioxide. What is the main composition of evaporation tablet? Now, sodium tartrate, citric acid, and sodium bicarbonate. Tartaric acid, citric acid, sodium bicarbonate. That's the main composition of evaporation. That's it, more than enough. Now you are going to discuss regarding different like excipient, diluent is there, disintegrant is there, lubricant is there. You have to remember the example. Okay, that's it. Just remember it. I don't need to read. You guys also know ABCD. I also know ABCD. So reading means like this. That's it. You also can uh, read as well as remember. I need to just give you the important topics what you need to read only. That's it. From where you will get most of the question. Okay, that's it. I don't like to do a lots of gossiping and all. One topic I'll take like 4 days, 5 days. I don't like all the things. Smart work I like the most. Okay, that's it. So next, different types of evaluation test you don't know regarding tablets like hardness is there. Hardness I did not this all the things important things. A few things I did not discuss like hardness, viability. Okay, hardness what are the instrument used? Like hardness tester is there, strong cob, uh, scrutineer, Pfizer, Eureka, all the things are there like for hardness test. Second, priority, Roche priority for 4 minutes, total 100 RPM per minute, 25 RPM. That's it. 10 tablet you have to take. Okay. Next, disintegration test. Disintegration test 6 tablet you have to take. 6 test tube. Each test tube having like length 3 centimeter, volume 250 ml or actually 900 ml also, 1 liter also most of the cases, as well as temperature 37 plus minus 2 degrees Celsius and RPM 28 to 28 to 32 RPM is there for disintegration test. A different disintegration time also there, like for normal tablet like around 60 minute, film coated tablet 30 minutes are there, like this different. You have to remember, no need to remember all the nonsense things. Okay, so try to remember these things. Dissolution also with different parameters are there, like RPM 55 to 75 RPM is there, temperature 37 plus minus 2 degrees Celsius. Different type of dissolution apparatus is there, type 1, type 2, like just remember this. IP, PB, PB, IP, paddle type, basket type. In case of ESP, opposite will be the basket paddle. Most of the time, these two only they will be asking. Okay, that's it. And different defects are there tablet: capping, lamination, picking, sticking, weight variation, mottling. Most important, mottling, lamination. Mottling very important. Lamination is more than 2 layer. Lamination, like we used to laminate the mark sheet. So mark sheet will be in between, above one part will be there and below also one more part will be there. Total 3 part is there. So more than 2 layer means lamination. In this way you can remember. Picking to the punch. P for picking, P for punch face. SD sticking, S for sticking, D for die wall. Weight variation will be variated. And mottling, very important this point. Mottling, unequal distribution of color. So this much enough. Hope I think I I I was very speed or very fast during giving the lecture, because I don't have much time to dictate all the things. You guys also feel boredom by seeing 1 hour, 2 hour videos. So I tried to finish within 40 minutes only of what I already told. So yeah, I did it. Please go through all the important topics, whatever I have discussed here. Please, again, I am requesting you to look this video, to watch this video properly, minimum 2 times, 3 times, as well as share with your friends or different colleges, so all the students from other colleges also will be benefited from this video. Thank you so much. Please subscribe my YouTube channel for to get more such important topics for different type of competitive exam, like GPAT, NIPAR, RRB, AIMS, as well as PGCET. This video specifically for PGCET. Please, Telangana student, I love the most. Hyderabad student, the student from Telangana, I love the most. So please go through properly. Wish you all the best. Please stay tuned for further video and subscribe my YouTube channel. Thank you. Thank you so much. Thank you so much. Okay. Okay. Thank you so much. I am completing this.